Hey guys, Mr. McKinney here, just talking about continuity of functions, and we're going to be dealing with piecewise functions in this video. So a function is continuous if the limit exists, the function exists, and those values are equal to each other. But when we deal with a piecewise function has two or more pieces. And so often we're going to look at the left side limit and the right side limit. So the value of the limit as x approaches c from the left would need to equal the value of the limit as x approaches c from the right. And so first of all, the limit from both sides would have to be equal to each other. And if those are equal to each other, then they are both, by definition, equal to the limit as x approaches c. And then if that limit is equal to the value of the function, then it is continuous, as defined in the other video. So again, for a piecewise function, you'd have to look at the left side limit and the right side limit, make sure they're equal to each other, and make sure that that's equal to the value of the function. So let's look at a couple of examples. All right, so in this function, it's broken up and it's defined one way for when x is greater than 4 and another way for when x is less than or equal to 4. So we know that at our function, x equals 4 is the interesting point. So let's use calculus notation. So the limit as x approaches 4 from the left, so let's think about for my function as x approaches 4 from the left, that would be when it's less than or equal to 4. So it's going to be x plus 4, and it's as x approaches 4, so that would be 4 plus 4, which would be equal to 8. So the limit as x approaches 4 from the left of f of x is equal to 8. Now the limit as x approaches 4 from the right would mean that x is being greater than 4. So coming in from the right, I'd be using this function. So 2 times 4 plus 1, 8 plus 1 is 9. So the limit as x approaches 4 from the right of f of x is 9, which is not equal to 8. So since the left side limit and the right side limit are not equal to each other, the limit as x approaches 4 of f of x does not exist. And since that limit does not exist, that means that the function cannot be continuous. Even though f of 4 does exist, because when x is less than or equal to 4, we use this equation. So f of 4 is 8. F of 4 is equal to the limit as x approaches 4 from the left in this case, and both of those are equal to 8. But this whole equation is not continuous. And if we think about it, at 4, when we're greater, we're up here at 9, and I'd have a slope of 2. When it's less than or equal to 4, I'm at 8. Whoops, there we go, at 8, and I would have a slope of 1. So I'd cross at 4. So slope of 1, slope of 2. And there would be a jump discontinuity there because there was a finite distance between the left side limit coming in at 8 and the right side limit at 9. All right. On this problem, I want to find the value of k that would make this function continuous. So in order for the function to be continuous, the limit as x approaches 2 from the left is going to need to equal the limit as x approaches 2 from the right, and those are both going to need to equal f of 2. So in order for this to be true, we need to find the k value so that all three of these things are equal to each other, and then that function will be continuous. So why don't you hit pause real quick and see if you can figure out what value of k it is. All right, most of you guys probably found the right value of k, but let's see if we wrote out the right notation, because in calculus it's extremely important to write the correct notation. So let's start with f of 2. F of 2 would use the top equation since that's when it's or equal to 2. So f of 2 would be 2 times 2 plus 3, 4 plus 3 is 7. So f of 2 is 7. Now let's look at the limit as x approaches 2 from the left side of f of x. Make sure you haven't put 2 in here. We're doing the limit as x approaches 2 of f of x, and in this case x approaches 2 from the left side. So that would be 2 times 2 plus 3. We're still using the top function because when x is less than, that's when we're approaching from the left. So that is equal to 7. As soon as I plug 2 into my equation, I don't need to write the limit anymore. So I don't need to write the limit statement here because I've plugged 2 in already. And then the limit as x approaches 2 from the right of f of x would be k times x, which is 2, plus 1. So that's what the limit approaching from the right is. And in order for this to be continuous, this has to equal 7, because it has to equal the value of the function and the limit coming from the left side. So 2k plus 1 equals 7, 2k equals 6. So the value of k that makes this function continuous would be k equals 3. So if this original function, had been 3x plus 1, then they both would have met at the point 2, 7. All right, let's do one more example. On this one, we've got a linear and a quadratic meeting, or potentially meeting, when x is equal to -2. So we want them to meet because we want it to be continuous. So again, hit pause and try to work this one out. All right, and then let's see how you guys did with the notation. So remember, we're trying to show that the limit as x approaches -2 from the left of g of x is equal to the limit as x approaches -2 from the right of g of x, which is equal to g of -2. All right, so let's do g of -2 first. That's going to use the top equation because that's the one that's or equal to. So 7 times -2 plus 2, -14 plus 2 would be -12. All right, then the limit as x approaches -2 from the left of g of x would be 7 times -2 plus 2, which would be -12. So the left side limit does equal the value of the function, which makes sense because we had the less than or equal to. So for the right side limit, the limit as x approaches -2 from the right side of g of x, I'm going to plug in my x value. So x squared would be -2 squared plus kx. I don't know what k is yet. X is -2 plus 4. And in order for it to be continuous, the left side limit and the right side limit would need to be equal to each other. So this whole thing would need to equal -12. So now let's work it out. 4 minus 2k plus 4 equals -12. -2k plus 8 equals -12. Subtract the 8 over. So -2k equals -20. So k would be 10. So in order for this to be continuous, k would have to be 10. That would have to be x squared plus 10x plus 4. And if you graph both of these functions using Desmos, they should both meet at the point -2, -12. Because at -2, we had one function, the linear function coming in, and then the other function, let's see, it would probably, I don't know, either look like this or potentially just be going straight up. But they would meet down there at -2, -12. All right, hope this helped.